Hello, my name is Cornejo, and this is LabActivity number 5 for EEE3303L. This one mainly deals with transistors, and here is the lab report I have written up. So we begin with activity number 5, part 1. The quick note is just that transistor 2N3904 was used for the whole activity. The collector bias is 10 volts with the low resistor being 1 kilo ohm. And when the voltage between the collector emitter junction is 8 volts, the base resistor is valued at 730 kilo ohms, and we can see that the transistor configuration is 4 active since the base emitter junction is the highest out of all of them. Here's the sorry, I got distracted. Here's the setup for the circuit so that I used the MyDAC, MyDAC, both the multimeter. And here is the multisimmer, so where it actually differs in the value for the base resistor. Well, it still gets me 8 volts, different value there. Here is the second lab activity, second part. VCE is 4 volts when the resistor on the base is 104.7 kilo ohms. And since the emitter bias emitter voltage is the highest, is 4 active again. Multi-sim provides the result in this case when the base resistor is 104.7 kilo ohms. We get the VCE is 6.245 instead, so it's a higher value, and our current results are also different as well. Much higher current read on the multi-sim simulations. It goes up to like 3.77, whereas on MyDAC it's capped at 2.22, and this is what causes the different resistor values to be used on base and actual experiment, because it causes the voltage drop across all of the resistors to be different. And here is when BC voltage collector emitter is 5 volts. The base resistor is 494 kilo ohms. We see that the transistor is 4 active again because the voltage emitter is the highest value. We get 5.14, it's close to 5 volts. And it's expected multi-sim simulation is different with the race resistor value. Okay, here you get part 2. The resistor, the base, there we go, the base and the low resistor, both at 1 kilo ohm. And here the measurements is we read to be collector emitter voltage at 15.8 millivolts, base emitter voltage at 0.710 volts, base collector voltage at 0.7 volts, and measure value of 0.7 in the base emitter indicates that the transistor is 4 active in and on, and the collector emitter does not match multisim because of MyDAC limitations again. Multisim is higher. And part 3, again the resistor and both resistors have the same value. Emitter bias is 15 volts, collector bias is 7.5 volts. Collector emitter voltage is negative 7.48, base emitter voltage at negative 7.5, and no voltage at the base collector junction. Similar results, nanovolts, basically 0. And here, when the base resistor is at 1 mega ohm, still the same bias values. We get the collector emitter negative 7.5 volts, base emitter voltage at negative 7.1, base collector voltage is a small value 4.3 millivolts. So here both transistors are in the cutoff state. Emitter base junction is reverse bias when it should be forward bias, as we can see right there. And also all the voltage values for base emitter junction have reverse bias. Base collector junction voltage had no forward bias, or just a very small positive forward bias. And here this resistor is in the saturated region because we can see the base emitter junction and the base collector junction are both forward bias, while collector emitter voltage is small voltage value. Here, this transistor, in this case, when bias voltage negative is 2.5, emitter bias is -5, and then the resistor is 1 megohm. The base resistor is 1 megohm, low resistor is 1 kilo. The transistors in the active region, base emitter junction has a forward bias, the voltage, and the voltage of base collector junction has a reverse bias. Voltage divider in that case for the different bias voltages. Here, part 5, we can see the collector voltage bias is going to be 5 volts. Both resistors are 1 kilo. This transistor is in active state. Base emitter junction is forward bias, and base collector junction has a small negative bias. So this is in the active state, the transistor. And in here, transistors once again is in the active region. Base emitter junction has a positive bias, while base collector has a negative bias. Part 6. This one is actually a common collector transistor. It's not in the configuration. It's not a common emitter anymore. And in this case, it's operating in the cutoff region. You can see the base emitter junction is negative, which is really. And that's it. Simple circuit, and that's it. That's activity number 5.